Okay, we'll start our session today on NGINX application security. I wanted to welcome all of you and thank you for joining. I have with me Chris Wittick and Daniel Edgar from the NGINX product management team. My name is Rajiv Kapoor and I do product marketing for NGINX security. So let's talk about what we're going to cover today. We're going to cover challenges with modern applications, securing modern applications. Then we'll go on to talking about the NGINX portfolio. And then we're going to talk about how security relates to both NGINX Plus and NGINX Controller. And then lastly, we're going to cover the NGINX offer summary. So let's look at the challenges. So we created this image to sort of show what the view looks like for the SecOps and the DevOps folks in an organization. For those of you who don't know what SecOps and DevOps is, as modern applications are rapidly growing, organizations have development teams that do the development coding of the applications and security teams that ensure compliance in organizations. And on the left-hand side of this image, you see the SecOps person, pulling in the DevOps person. And essentially, this is to ensure compliance in the organization. And that is the SecOps view of DevOps. So we have an organizational challenge here where SecOps people think that developers are just going around freely, not really abiding by the compliance and policies set by the organization. And for the SecOps, this leads to rope burn because there's a lot of stress and hypervigilance around monitoring each application, sometimes on a case-by-case basis. And it leads to friction in the organization. On the right-hand side, this is the DevOps view of SecOps. Here we see developers wanting to be free, create rapid applications. They want velocity. They want to get to the market quickly, but then feel weighed down by SecOps. And they feel like they can't do their jobs. And SecOps is a problem for them in doing their jobs. Again, this leads to friction between the DevOps and the SecOps. So let's talk about the pain points. From the market, the overall market, there's just a lot of different architectures, containers, microservices, open source software. And all of that gives rise to more vulnerabilities as a result because of the diversity of architectures that exist out there. And then some of the same vulnerabilities that existed before continue to exist 20 years from the past to now. And the other issue is that the organizations lack consistent policy. There's a bunch of different applications within organizations and they're inconsistently managed. And the cost of security breaches is pretty high. It's downtime, it's customer satisfaction, and it's lost revenue. From an application development standpoint, app development has really changed and evolved, and to agile, quick updates to applications, time to market, so on and so forth. The developers are mostly in organizations, they outnumber security professionals to as much as 100 to 1. And then developers have time to market pressures. There's frictions. They perceive security as a bottleneck for them to be able to do their jobs. And as a result, it leads to poor testing, lack of a consistent process, and oversight. From a SecOps standpoint, SecOps is typically understaffed, and the threat landscape is constantly evolving and changing. So to keep up with it is not easy. And business leaders, they have a lot of pressure from the business leaders to make sure things are compliant. So they're really looking to make sure that we don't break any policies within the organization. And inconsistent security policies create risk, because we don't, an organization doesn't have one single view through which they can look at what tools are using what policies and are they all aligned. From a DevOps standpoint, security slows down the app dev cycle because they have to probably send an email or talk to somebody or have a meeting. The CI/CD pipelines that automate applications lack security because security is a pretty highly specialized skill set. And then business imperatives like time to market, and that DevOps folks don't really think of security as a KPI for their jobs. From an app dev standpoint, developer training on security is lacking. It's developers. There are developers that know about security, but essentially the training for the developers is not as robust. And then developers are focused on app development and not able to stay abreast of the security landscape. Pretty similar in some ways to the SecOps people, but at least the SecOps people are engaged in security daily, whereas developers aren't. And as I said earlier, the open source software introduced unknown risks to businesses.
So, hey, Rajiv, I appreciate that was a great intro talking about some of the pain points and challenges. One thing it'd be interesting to notice, how do we align those challenges to the code to customer story? So a lot of times when F5 talks about the portfolio of products that F5 offers, and that includes NGINX, they talk about it from the context of the code to customer story. Can you illustrate what the code to customer story is, and how does it relate to security? How does it relate to those pain points that you just mentioned?
Sure. As far as the code to customer story goes, at the bottom of the slide, you see what we call as the data plane or the data path, which consists of application services needed to ensure reliable access to the applications. And at F5, we look at, and we think of the data plane as where the traffic flows between the application to the end user. And so when with the modernization of applications, it is becoming increasingly challenged who owns what and how they look at security. So if you go to the next slide, here on this slide, we think of application services as including both application delivery and application security. And that means that there's going, with the modernization of applications, SecOps has to think about what are the different ways to secure different applications? Do we need more than what we have today? Whereas app developers think of security from an app-centric standpoint, and the infrastructure people or the infrastructure organization and/or SecOps looks at it from more of an infrastructure standpoint. And so challenges can emerge in coordinating these application security policies across the data plane. And one of the ways we look at, and I think I'm going to talk about it in the next slide, which is one of the ways we look at the data plane is that we want security as a horizontal capability across the data plane and not so separated from it. So here we talk about, on this slide, we're seeing a sample of, in an enterprise, there's typically 700 to 800 applications deployed. And they're deployed using various architectures, cloud environments, microservices, containers. And what happens is, as a result, different groups and different teams select their own best of breed tools and apply their own sets of policies and controls over those tools and or applications. And then there's also tool sprawl, because there's all these little tools across the organization that are sometimes not even tracked well. And so it gives rise to operational silos, complexity, and ultimately friction in the organization.
So Rajiv, that makes sense. There's too many tools. There's too many silos, and that helps reinforce some of those challenges and pain points that you mentioned. So So what can customers do? How can customers simplify that code to customer story?
Yeah, I think the key here is to kind of understand is that app services include both app delivery and app security, and they work together in tandem. In other words, they reinforce each other, and so we want to give the ability to embed security along the data path, as I said earlier, which is a horizontal capability. It could also be through security as code, which Chris is going to talk about in his slides. It's also through applying policies and controls consistently across the organization from one single place. And then using the insights and the telemetry from those services, giving visibility to the SecOps teams to know if the organization is compliant. And to continue with that, the way we think of the control plane is a single place from which you can orchestrate and automate app services across your organization. And this is a place where you get a view into per application view into what services are being leveraged, what policies are being applied, what threats are being seen, so on and so forth. So a single place from where to have all your business insights, a single place to secure your modern apps, and resulting in reduction in operational complexity. So Chris, we talked about the challenges that organizations are facing securing modern applications. What can customers do to address these challenges? And what is NGINX doing to address these challenges?
Thanks, Rajiv. Yeah, I think that was a great introduction, right? I mean, and I'm sure there's, a lot of the people who are attending, today's presentation, today's webinar, regardless of which side of the fence you're on, if you're on the development side, you're on the security side, you're on the infrastructure side, a lot of these challenges resonate with you. But what are some of the real world impacts on that, right? Well, what are some of the things that we see and we hear from our customers? Well, one, these challenges can definitely impact your pipeline. Many of the security tools we see our customers using, they were created for fixed perimeters. They're legacy tools, right? So a lot of times with those types of legacy security tools, there's just a few connections they were asked to secure. And often they've tried, customers have tried to evolve their security approach by leveraging these same tools to help secure more modernized infrastructure, modernized applications. But those tools, frankly, aren't built for the task. And this is challenging because dev pipelines today are built for speed. They're not built for security. And many security tools are not keeping up with modernizing operation models. Inserting security into modern dev pipelines means relying on automation. But these legacy tools aren't designed for automation. The security teams themselves, they acknowledge these challenges. And as you just mentioned, security teams suffer through staffing challenges, especially finding the right people who understand both security and code, essentially staffing the DevSecOps persona. And also, the challenges relate to modernizing applications and modernizing infrastructures. We all know, we've talked about it. Organizations today are transforming how they build and how they manage applications. And they're doing that by leveraging different types of cloud environments, different types of tools, different types of infrastructure environments for deploying these applications. And this can lead to challenges in understanding the unique security requirements each environment may have. According to the 2020 State of Application Services report, this is a report that F5 produces on an annual basis, 87% of organizations are leveraging multiple cloud environments as they shift workloads and applications to the cloud. However, each cloud environment represents a different attack surface that must be secured with different types of protection required for each environment. This leads to a really important question. Who owns securing this cloud infrastructure? Oftentimes people misinterpret the role of the cloud provider themselves. They're assuming cloud providers are taking on more responsibility for securing the underlying cloud infrastructure than they actually are. And in many cases, that's your responsibility. And so a lot of the security challenges we see is out of date and not updated cloud infrastructure. And then additionally, the applications themselves for modern applications are really just a collection of services interacting with each other via APIs. And these services can exist anywhere, with data flowing between containers, between users, between devices, etc. Where with a monolithic application, you may just have a few self-contained services. Services for modern applications can exist anywhere, using all kinds of different technologies. This can make it very hard to understand where an application starts and where it stops. And this is, we've seen some breaches that relate to this as well. A lot of the very public breaches have been examples in securing newer or more modern applications. These attacks have often bypassed traditional north-south security, instead attacking an unprotected surface or service to get in on the side. An example here, and this is one of my favorite examples, there was a Las Vegas casino that was hacked through a smart thermostat in a fish tank. Once the app behind that thermostat was attacked, they were able to bypass the traditional edge security to gain network access, showcasing the importance of not just relying on traditional edge protection, but shifting protection closer to the individual apps and the individual application services themselves. And network infrastructure teams, they have experience in securing on-premise infrastructure. But as workloads and applications shift to the cloud and as the services shift to these cloud environments, in many cases, the cloud infrastructure is owned by the application teams themselves. This effectively decentralized security across many different development teams and app dev teams and DevOps teams within the organization. Securing this expanded service can be challenging for overburdened security teams. And this leads to a lot of that friction, that regime that you mentioned about between the various DevOps teams and security teams. And it also can lead to the development teams attempting to work around security requirements for the sake of speed, for the sake of agility, for the sake of time to market. This is another example of that shadow IT challenge we hear about, where the development teams themselves are either bypassing security or taking security in their own hands. And this can lead to compliance challenges for the organization. These all ultimately lead into a lack of confidence in securing modern applications deployed into modern cloud environments. That same 2020 State of Application Service report I just talked about, only 15% of respondents were very confident that they could withstand an application layer attack in the public cloud. And 58% of respondents said the most difficult part of managing applications in a multi-cloud environment was maintaining security, maintaining policy, and maintaining compliance. And this all leads to additional challenges relating to the overall performance of your applications. Many customers, many organizations attempt to secure this expanded perimeter by throwing a lot of different tools, a lot of different security layers, and a lot of manual processes that can interrupt the development pipelines. This is that silos approach that Rajiv just mentioned. Different applications, different teams, different tools, creates a lot of different organizational silos and a lot of different approaches to applying security within those silos. This can impact application performance. Having too many different tools and too many different processes and too many different silos can really impact visibility as security teams are looking to aggregate information across different tools and correlate that information in a useful manner. And it can encourage security not be practically applied, kind of that shadow IT example I just mentioned. So the result is frustration and friction, with both the DevOps teams and the security teams having a hard time determining what is normal and what is abnormal across all the different applications they're asked to secure. So what can you do about it? And there's, I'm not going to say there's one way to address these security challenges. There's a lot of different approaches. There are a lot of different best practices. So I'm just going to provide some examples that, I've seen from customers and we've seen from customer conversations. Is one, invest in lightweight and agile security controls specifically for your modern applications, specifically for your pipeline. Controls that can be embedded by your DevOps teams into your pipeline using automation. As we just mentioned, you're never going to have enough security people to throw out security. So automation is your friend. It helps simplify the job of both your development team and your security teams. Also, segment or compartmentalize your modern apps, your microservices and your container environments so you can apply security controls on a segment by segment basis, with some sort of logical ingress point serving as a control point for that segment. This implies a much different trust model than kind of legacy network security. But it also allows you to apply security more effectively than possible with a monolithic application. For example, if security for a monolithic app fails, your entire app might be compromised. But if security for a specific segment fails, but your security controls prevent that attack from spreading to additional segments, you have a much smaller blast radius to worry about. And lastly, keep an eye on performance. This is something I just talked about. There's a tendency in security sometimes to layer in too many tools. We talked about that, the challenges there. This is not to say that defense and depth protection is not a worthy goal, but you just need to make sure you're selecting the right tools and layering on tools in an effective manner, right? So it's, shifting security left doesn't necessarily mean throwing a lot of tools at the problem. It means applying effective tools that align to the problem you're trying to solve. and otherwise performance for your application can start to suffer. So what is NGINX doing? What is the role of NGINX security? A lot of you may be wondering, you don't think of NGINX as a security tool. You think of NGINX as a market, leading the best of breed, open source NGINX used by hundreds and hundreds of million websites around the world. So what's the NGINX approach? What are the investments we're making? Well, this is something that we'll spend the rest of the presentation going into more detail on. Well, one, NGINX is investing in security solutions that can be implemented by DevOps teams and SecOps teams and used within your pipeline. Solutions that make it easier to secure your applications in a wide range of environments without having to trade off performance for security. Our goal is providing you, your security teams, choices and flexibility where they can deploy security services. So we want the DevOps and the DevSecOps teams to be able to deploy services and security specific to an application or right by the application itself or the application service. And the NetOps teams, your infrastructure teams, and your broader security teams have choices also for securing infrastructure and groups of applications. We want to be able to provide you that flexibility in how you want to deploy security. What we want to do is provide you with the ability, and your security teams, the ability to provide development teams with security guardrails and guidance. This is something we hear a lot. We hear consistently from the DevOps teams within our customer base. What we hear is, we want guardrails, not gates. Don't slow us down, meaning provide the appropriate guidance and tooling to insert security into the pipeline versus dropping a gate that interrupts development anytime a security review or conversation needs to happen. So let's go into some examples. Let's talk about, more specifically what we're talking about. So first off, let's set the stage here. Let's talk about the NGINX portfolio. When we talk about the NGINX portfolio, we talk about it effectively in two different layers. Layer one is the data plane. This is represented by NGINX Open Source and NGINX Plus. This is something probably a lot of you on this call today are very familiar with. NGINX Open Source is used by, as I just mentioned, hundreds and hundreds of millions of websites around the world. It's used for a lot of different use cases. It's a great fit-for-purpose tool for specific scenarios within that your development teams are trying to address. Layer two is the control plane. And the specific offering we offer there is the NGINX controller. What we're doing is we're investing in application security for each layer. Security for the data path is optimized for customers managing their underlying infrastructure directly, allowing you to build in fit-for-purpose security depending on how you're leveraging that data path. We'll go into more detail on that in a second. Security for the control plane is optimized for specific control plane use cases, such as application delivery and API management. And we want to simplify how security is inserted into those use cases. For example, providing security for the delivery of specific applications, and we'll go into more detail on those security options throughout the rest of the presentation. So let's start with the data plane. Let's start with security for NGINX Plus. So just a refresher, NGINX Plus. NGINX Plus is ideal for organizations building out a fit-for-purpose data path with the targeted build your own control plane. So you're bringing in your own automation. You're bringing in your own orchestration. When it comes to security, we're layering in security in the form of a brand new product. It was released just a couple of months ago called NGINX App Protect. And this layers in security for the main NGINX Plus use cases we see from our customers. So being able to apply security as an application or a web server when NGINX is used as that, or as an ingress control point, or as an API gateway, or as a load balancer. So what is NGINX App Protect? Well, I'm going to provide a high-level overview of NGINX App Protect, and then I'm going to hand it off to Dan, who we introduced earlier, to provide a demonstration on it. So really, NGINX App Protect is a lightweight web application firewall that's based on F5 IP. This allows customers to shift app protection closer to your applications and your application infrastructure. And what it provides is strong and high-performing security with trusted signatures from F5 and backed by F5 support. And what we really want to do is to really emphasize the fact that this is not a port of traditional F5 security. This is designed for NGINX. So we basically redesigned F5 IP in such a way that it could be optimized for NGINX. So it's designed for how our customers are building and deploying their applications. App Protect is deployed as a lightweight module designed for NGINX Plus and the environments that NGINX Plus supports. And thus, kind of related to the points we mentioned before, this allows you to shift security closer to your application and insert security policy as code into your pipeline. So easy integration into your CI/CD pipeline. And it can be deployed in numerous environments. At this point, I'm going to pass it over to Dan, and he can talk about the various different ways in which NGINX can be deployed.
Thanks, Chris. So traditional infrastructure NetOps folks might be interested in putting a proxy layer via NGINX Plus out in front of multiple applications. NGINX App Protect can be installed on that tier because it's lightweight, it's flexible, and it's high performance. But for modern applications, they may be interested in managing that from a DevOps perspective, from using a container automator and orchestration solution such as Kubernetes. You can also deploy it as on your ingress controller as an entry point into that cluster. Further yet, again, because of the flexibility of the platform and the lightweight footprint, you can deploy it as a per service proxy, providing application security services inside your cluster as well for multiple pods. And finally, you can install it very surgically for one or two particular pods as a per pod proxy. A potential use case there is I've got an application that may have security vulnerabilities, but it still provides a lot of business value. I may choose to implement stricter security policy settings closer to that application. Another scenario related is a particular service might deal with sensitive data, PII, financial data and things like that. I might want to add additional protection against exfiltration of data with NGINX App Protect at that particular insertion point without affecting the rest of it. So again, the theme is flexibility and deployment because it is lightweight. It can go many of the places where NGINX Plus is going now, as well as continued use cases into the future with subsequent releases.
All right, thanks, Dan. Let's turn it over. Let's stop the share and turn it over to you so you can provide a little bit more of a detailed, in-depth overview of NGINX App Protect.
Sure. And I am going to share my desktop. And one of the reasons, Chris got into it with one of our main priorities for NGINX App Protect is it had to be easy. It had to be easily consumable, not only lightweight, but had to be a solution that did not require all teams to pivot to use third-party systems of record or installation or deployment processes. It had to work within your particular CI/CD pipeline. It had to work within your ecosystem of source control management tools. It had to work within your usage of your DevOps configuration management tools or infrastructure automation tools. And it does exactly that. So the very first thing we're going to do is I'm just going to show a sample installation of NGINX App Protect and do a very basic trial in terms of what of actually testing its efficacy, and then we'll talk about ways that you can implement this in your particular workflow or your particular DevOps pipelines. Along the way, if you have any questions, please be sure to put them in the Q&A. So I've SSH'd into a CentOS 7 image, and I have NGINX App Protect as a certificate and key available to download from our package management tool. And one of the nice things about App Protect is we're going to use the package management tools native to the OSs that you prefer, the distributions you prefer to deal with. No proprietary installation tools necessary. And what's going to happen is when I install App Protect, I'm going to either go to my public repositories, which we make available where you download NGINX Plus and other components from. But in this particular case, I'm going to pull it down from a private repository I have using Artifactory. And this is important because a number of companies that are security conscious might want to vet those packages ahead of time, or may not want their build or worse yet, production servers to be able to pull in their own packages. So because we're using those common set of tools, things like package syndication to your own environments is certainly possible, and we recommend doing that. So NGINX App Protect has been installed with a basic policy at this point. So let's take a look at those particular elements that make up NGINX App Protect. So from its simplest point of view, NGINX App Protect can be run with as simple as just 4 JSON properties. So when we say infrastructure as code, JSON is the format we have chosen, which it works very well. It's versionable. You're going to put it in your GitHub repository to manage that as code. When you want to make changes to it, your pull request or your merge request process to be able to look at updates. But it is a lot more flexible in terms of being able to work within your pipeline when choosing those common files, rather than something, like a very large XML file or a binary file. So again, emphasizing that your system of record is in your Git derivative. But this is a simple policy file. You name it. The template for this particular policy, we ship with one policy that is used as a template or starting point for your application security journey. And that's a balance of security efficacy, which is going to include things like OWASP top 10 coverage, RFC compliance, and things like that, balanced with usability. So something that's able to get going very quickly, but should require, only a minimum of tuning for your particular application. Then you specify your application encoding type, UTF-8 in our case. And one of the most important things as part of this policy file is I need to specify an initial enforcement mode. I can specify either blocking or transparent. So if I'm working with an existing representative sampling of traffic on my particular website and I want to, or my web application or APIs, and I want to insert NGINX App Protect, I could always deploy it in a transparent mode to be able to look at the security insights, the security events, to shine a light really on how people are using or abusing the application without actually doing any enforcement at that point. But for demo purposes, I'm going to be blocking at this point. So another file that I think we need to look at is the logging policy file. So anything to be considered an enterprise grade WAF needs to have the ability to generate actionable security insights, right? But not too many. So this logging policy file provides you the means to decide which events to send to your analytics or your SIM engine for further triage and investigation and tuning. So in this case for the demo, we're going to do all request types. But I also have the ability to really specify what that logging format looks like. So out of the box, NGINX App Protect uses the syslog logging format using a name value pair scheme, but I can always override that to log to a file instead if I wanted to. To change the format of the string, I could change it to JSON. I could change it to Splunk, which we have a format for out of the box. I could change it to ArcSight, common event, if I wanted to right out of the box. So again, you have that flexibility to ingest the logs however you want them in your analytics engine of choice. And we're going to look at one a little bit later. So I also have the ability to say, max request size, max message size, because space is important. And if there's a lot of noise in your security logs, it might distract you from the things that actually need action taken upon them. So, and finally, it comes together in the NGINX configuration file. I'll show you that. So you declare that module, the dynamic module that we provide for customers. It's pre-compiled, it's ready to go for our distributions. You install it and you declare it at your global scope in NGINX. Now under the server settings, I'm going to have a master switch to be able to enable App Protect per this context to enable the logging. This is where I'm bringing in that policy file that I'm referencing in my in NGINX, and here's that security log. And right now I'm referencing that default security log policy, as well as sending syslog, currently configured to send to Logstash, which is part of the ELK stack, which we're going to look at a little bit later. So let's see how this works. Okay, I need to start NGINX. NGINX is started. Once it's started, I'm going to go to the sample application I have. And I have to log back into my demo environment. Okay, I have OWASP Juice Shop stood up. Juice Shop, if you're not aware of it, is provided by the OWASP Foundation. It's an academic learning environment to help you understand web application vulnerabilities, not only for security professionals, but also developers, and how to defend against them, to identify them in terms of what they look like. It's designed to be a vulnerable application, but it's also a great resource by the OWASP Foundation that you should definitely check out in terms of your application security learnings. But I'm going to do something very, very blatantly obvious. I'm going to, this Juice Shop application is running in a Docker container protected by NGINX App Protect. So I am going to do something very obvious, I'm going to inject it with a cross-site scripting vulnerability triggered in the URL, right? So a cross-site scripting vulnerability by default in our policy is something that's unmistakably, in a URI, unmistakably looking like an attack. So NGINX App Protect has high confidence in it and low failure rate in terms of being able to say, I can positively identify that that's someone trying to do something nefarious against your system. So it did block it because it had a high enough severity, again, with that default profile. But what I'm seeing here is a block page. So this is an HTML-based block page, and I can certainly customize this. And how I customize this is I'm going to go back and I'm going to modify that JSON file to extend it for the particular needs of my company. So if I need a particular branding, or if I want to redirect to a different page for a block, I can certainly do that. Secondly, if this is a SPA application with the APIs back behind it, the APIs are going to be emitting JSON code with RESTful, using RESTful verbs, and of course REST-based or HTTP-based status codes, right? It can't read markup. So I might go in for this particular application and customize it to return a particular status code in a blocking scenario. The other thing I want to call your attention to is the notion of the support ID. Now, this support ID is unique for every particular violation. So if I was to sit here and refresh the page, it's going to change, right? That's important in the tuning process or in the triage process. So if this particular support ID is found by someone early on in your QA environment or one of your developers when doing something that they thought is legal and it's in the context of your application, this ID is going to be useful in determining what actually happened in the logs in the dashboard of your choice. So again, it helps enable that round trip journey as part of what's going on. So NGINX App Protect, it installs at a set of packages. Secondary to that, part of the value of it is you don't have to maintain your own signatures, but we do want you to subscribe to regularly downloading the signature update packages, which are issued, between 3 and 6 weeks, depending upon severity. So when a new vulnerability is found out there that we don't have coverage for, we're going to put that out there. Our threat researchers are going to do the research, put together a comprehensive rule for it, package them up, and then you can adjust them as you see fit. So how do I do that? When I install NGINX App Protect, I've got really a base level of packages that were available at the time it was published. So they install, unsurprisingly, as a second package. So I'm going to install the latest App Protect signatures from my repository. And again, this is syndicated. I've syndicated it to my internal Artifactory, so I can pull them in, I can vet them in a lower environment as part of a dev or test, functional test pipeline against my application before I choose to deploy it to my fleet of NGINX instances out in front of my applications. This one takes a little bit because my Artifactory is very lean in terms of compute. All right, so App Protect signatures have been updated. 2023-16 is the latest version in my Artifactory environment. But how do I apply them? It's in a non-disruptive way. You simply need to do, with the power of NGINX Plus, I can reload that, pick up the new versions of the signatures, not in a non-disruptive way in terms of traffic. It's going to, as connections are terminated, it's going to start new worker processes to accept those connections and process that traffic with the newer versions of the signatures. So when I go refresh my page, it's still blocking. Okay. So that's a high-level overview of how you might use something like NGINX App Protect in your environment. But how do you introduce, with the notion of introducing security on early, the idea of shifting left to be able to get things into terms of developers within their environments, it's technically possible, and we recommend you introduce security as early as possible, right? Put the configurations, put those particular policy files over in your source control repository with your code so they can be deployed as a unit. Secondarily, it allows you to, rather than evaluating the security of an application or the protection that a security solution could provide, introduce it early on and check regularly. So rather than having a stage gate prior to going to production to evaluate the security of your application and potential delays that that causes within your value chain and additional friction associated with getting your application out the door, we recommend you introduce those security functions earlier. So I might choose to, in my particular environment, implement a dynamic scanner. So for this particular case, I've got OWASP Z attack proxy that I'm going to use as a scanner in my environment to check to see what's going on in that application, to check to see if I have any vulnerabilities. And I could run this in my CI/CD pipeline. So if I was to introduce a tool like this, a static security scanner or a dynamic scanner, I would want to know if I have any security holes. I would want to know if I have any usability issues related to automation testing before my customers do, before infiltrators or attackers do. So run this early, run this often, even using free tools like Zap is our recommendation. So my next step would be introducing an automated build for this sort of thing. So we're looking at my particular CI/CD pipeline is Jenkins, and it's looking at a repository here. I've got my app protect log policy file in there. Every time I make a commit to this GitLab, it's going to be pushing that policy out with my application to that environment. And I've introduced stages in my internal build at this point, so I can build my environment. I'm going to install NGINX App Protect. Back there would be, building my application as well, but I could do an initial smoke test to make sure that functionally I can get to my application. But then I can do a deeper DAST test using something like Zap or other third-party scanners to do that. And then if any of those processes failed, I would kick it out to be addressed. So if I'm going to have somebody that looks at the policy, oh, there's a vulnerability we're not protecting against, I know early on. And as a DevSecOps professional or even a developer, I could go in and look at it within the context of my application, make any changes to the application or any policy that's needed, kick off the workflow again and deploy to production with the application. So in terms of visibility though, what do you get out of the box? So I have here a dashboard that for NGINX App Protect that is ingesting those syslog messages into the Elk stack, indexing them with Elasticsearch, and displaying in a custom Kibana dashboard. And this particular dashboard we make available in open source out in GitHub to customers, complimentary. We have an overview dashboard, which is the first one we're looking at, as well as a false positives dashboard. And this particular overview dashboard was within the context of a scan I did earlier in using the Z attack proxy. And what you're seeing is a broad amount of attacks and signatures that were triggered and the different types of violations from a particular violation IP. I was running my scanner from one IP, which is why it shows as a single violation. But I could run this, obviously, if I'm running this in production, I'm going to see a broad swath of not only good uses, so good clean traffic, as well as block traffic. The third state here, some things look suspicious but require further examination. NGINX App Protect has a mode where if the violation is not extremely severe, it will simply alert on it so you have visibility to it, and then you can investigate whether or not it's something you choose to block later or not. But again, this is this default posture of the default policy. I could customize anything that may have been alerted to block entirely for my application if I chose to. So here at this point, I'm looking at violations, and here's your bad one, attack signature detected. I'm going to filter by this in the dashboard. Geolocation would be there if it was on a public network. So for this particular item, I'm going to look and see what happened from an NGINX App Protect perspective. So here was the event, the timestamp associated with it, the IP, the source of the potential attacker, what we did with it. We rejected this request. So if it was a user that was actually, not using the scanner tool, but was using an application, they might see the block, right? That block page. Why? Because it was a WAF violation. I have that policy name, which is important because I need to know which policy to go back and make changes to if I deem that necessary. The actual request, what we did with it, any signature IDs that were triggered, the names of those particular things that were happening in this case, the details related to that violation, and most importantly, that support ID, right? So that support ID that showed up earlier, that I showed earlier on the blocking page. Support IDs are useful for the notion of addressing false positives. And when I say false positive, generally WAF technology, it's designed to enforce, amongst other things, as well as looking for poor behavior, but designed to enforce RFC compliance, right? So if your application might be violating something that is in an RFC, but your browser is lax enough to allow that, you might want to tune that for your particular application. And to do that, how am I going to explore what that might look like? So we have a second dashboard we make available called false positive. So in that scenario of RFC compliance, did I click on that? Is it loading? There we go. So the idea is, generally speaking, if I see a number of attacks from a single source or a couple of different sources that is a broad, assortment of violations, that's probably somebody doing a pen test, it's kind of a white hat kind of a thing. Or it could be somebody running a security scanner looking for vulnerabilities for malicious intent. However, if I'm seeing particular violations across a broad swath of source addresses, that might be something that I need to address. So that might be something I need to tweak in my particular application policy. So if I see that and I determine a change I need to make to my policy, I'm going to go back to my policy and make that change. If there's additional things I need to change within my security policy, I can make those changes at the same time. I can add an exception for that signature as well, or choose not to block on it, but continue to monitor it. Something else that NGINX App Protect has, I might choose to use at this point, and that is the feature we call Data Guard. So I'm going to choose to add the Data Guard feature to my particular policy before I commit it, and my CI/CD pipeline runs and tests and deploys the application if all the tests pass. But Data Guard is designed to provide protection against responses. So think of data leakage situations where I have made a particular malformed request, or my API is not protected, and for PCI compliance reasons, I need to ensure absolutely that no security, social security numbers are being sent out from a server. I need to be able to make sure that absolutely no credit card numbers or server-side error codes, what have you, are being protected. I can enable this at this point. And again, the practice is commit this to my pipeline, make that change, run my security tests, and deploy in production. So that's how I would do that. And there are many resources available in the NGINX App Protect site, particularly the documentation page, that is going to show you how to make changes to your policy in your lower environment. Make those changes, absolutely validate that you're doing your automated tests against them, and then deploying your application so you have security efficacy in mind. Okay, that's about all I had for the demo.
Fantastic, Dan. Thanks. I'm going to bring back up the webinar, and we're on the home stretch, everybody, so we're just about done. All right. You're muted, Rajiv.
So Chris, what can enterprises do to secure their applications in such a distributed and diverse environment?
Yeah, thanks, Rajiv. So we mentioned earlier the value of a control plane, and we haven't really dove into that. So just for the last few minutes we have, we'll jump into that. And I do want to say too, for those of you that may have had questions during Dan's demo, feel free to ask me Q&A. In fact, Dan, there is one question in the Q&A tab that I think would be good for you to maybe answer in the comment section there.
Yeah.
Go ahead and just answer it offline in there.
Will do.
All right. So we introduced NGINX controller briefly up front, and what is the difference between NGINX controller and NGINX Plus for the data plane? And really, it has a lot to do with the view that you have within the controller. First and foremost, controller does provide an effective way to manage NGINX Plus at scale, right? So it allows you visibility and an easy way to manage your NGINX Plus environment. But it's more to it than that. It's also the ability to inject an app-centric point of view. NGINX Plus is very much, as I mentioned before, fit for purpose. So you're designing it for specific applications, specific service specific set of infrastructure. Controller is for that distributed environment where you want to have an easy way to allow your development teams to manage the APIs, manage the delivery of applications at scale. So it has an app-centric interface that allows you to set up and manage applications on a per application basis and have policies associated to those applications. The visibility is per app, so you get a perspective on each application. You can interface with controller through a GUI or through an automation-driven API. So your development teams, your DevOps teams will be very familiar with that. And it's easy to delineate access to applications by team, by workflow, right? So you can have very specific tasks handed out to application teams for the specific applications they mentioned, for the DevOps teams, and also for the security teams. And this helps reduce the friction because you're not getting in each other's way. So really with controller, NGINX controller provides that easy approach to enabling application services and providing a standardized approach to how you might manage the deployment of applications, how you might manage the API interactions of your application. So it's very much use case driven. And the two use cases we focus on today are ADC and API management. There are horizontal layers to that. So analytics provides that point of view into the performance of your applications, that point of view into how you manage your APIs. And then we're introducing security as a new add-on that allows you to layer security into, first we're going to start out with application delivery, and then later on we'll add it in for API management. Just a little bit more details. We'll go through this fairly quickly. This is something I mentioned, it's a feature, but it's in beta right now, and it's going to be commercially available later this year. And kind of the levels of value that controller adds is as follows. First and foremost, it's for inserting security into the deployment of your applications, leveraging that exact same NGINX App Protect module that Dan just went through. So controller's taking on, along with kind of the management of the data plane in NGINX Plus, also the management of App Protect. This makes it possible to have security policy lifecycle management deployed as part of the automated application deployment that the controller supports. So you can actually insert it in to your pipeline via the controller APIs. But it's more to it than that. There's also this idea of insights that are relevant towards your development teams, your security teams. So we have security dashboards that are application specific and pertinent to the roles that are managing those applications. So the development teams, the DevOps teams can see how security is impacting the performance of their applications, and security teams can get more of a holistic view of how security is impacting all of the applications that are being managed by a controller. So it really allows you, security teams, to see how security is impacting the traffic to applications and the application performance. And kind of this last layer is this idea of self-service. So it enables your development teams and DevOps teams to add security to their applications, but specific to the applications that they themselves manage in a self-service managed fashion. It really helps with setting security options as guardrails. That really relates back to what we mentioned before. Security policies can be automatically aligned to applications by the profile set those applications. So security teams can do their jobs and set the security guardrails for the organization, and the development teams can then align security with controller really providing that assist automatically to their applications. And of course, security has the ability to audit that to make sure that the right type of security was added to the application and they can have that compliance view. So to summarize, controller enables organizations to deploy app protection easily in a standardized way, in a self-service fashion for the various app teams, DevOps teams within the organization, and providing the security teams the control and the visibility that they need. So that's kind of it. I just wanted to end with a quick summary. We've talked a lot about the application offers within NGINX. Ones we didn't cover is mod security. I just want to briefly touch on that. So for those of you that use NGINX open source, mod security works great with NGINX open source. It's available as open source. NGINX is available open source. So a lot of you probably already have exposure to that. We do sell a supported version of ModSec for those that want the support of basically a supported version of ModSec to go along with the supported version of NGINX Plus. That's available to you now. ModSec works great for kind of that basic WAF protection. It can run into limitations related to performance for high-performing application, and it can run into limitations in terms of really how you manage signatures for compliance-specific applications. That's where NGINX App Protect is perfect, and we just talked about that. And that was released earlier this year. It's available for anybody that wants to try it now. And then for those that want to move beyond kind of that protection on a per fit for purpose basis, where you're building in everything for that application, but want to have kind of a standardized way to inject automation and orchestration to a broad set of applications and inject security as part of that story. That's where we just talked about. That's where NGINX Controller is perfect. So I know we're running close to end on time. Want to pass it back to Rajiv to to tell us how all of you can learn more about NGINX security. And for those of you that have questions, feel free to keep shooting those into the Q&A tab.
Thanks, Chris and Daniel. We have a free trial of NGINX App Protect that is available online at the link that's mentioned on the slide. You can learn about it online too on the webpage. And if you want more information, as Daniel said, you can look through the release notes and actually see how to do certain things with App Protect. And as far as the controller goes, we also have a free trial for NGINX Controller, and the link below will take you to the page where you can get it.
And Rajiv, just one thing I'd add there too. Just we mentioned that there's the application security for controllers in beta. If you're interested in that, I would say start a conversation with your NGINX account rep or sales rep, or your F5 account rep or sales rep, right? So that's where we can get you access to that AppSec beta as well.
That's right. Thanks for that. With this, we conclude our webinar today. I hope that this information was useful and helpful, and we look forward to engaging with you going forward. Thank you.